Good evening, dear participant, and I hope I am audible to all of you. Just I wait. You have to wait for 1 minute, and we are going to start. I think everything is fine. Okay, and many participants has joined us. Okay, uh, so this is okay, and I have to open. Okay, sorry for interruption. My system was shut down, and now it's fine. And hope all the things will be very fine. You can see this is the session. This session is based on Symbolic Math Toolbox. Okay, and these are the content which we want to cover in this session. The agenda of the content is how we can create a symbolic function, create symbolic matrices, and perform symbolic computations. Under this session, there are some functions like operators, derivatives, integrate symbolic expressions, solve equations, simplify symbolic expressions, substitution and symbolic expression, plot symbolic functions. So these content we are going to cover in the present session. So as you can see, I have the MATLAB. Okay. So we need MATLAB. This is the MATLAB window, and this is the presentation. And sometimes we need these text also required. And I have to need to open one more file so that we can do smoothly all these things. Just 1 minute. Actually, the system was shut down. That's why I have to restart, and I got 2 minutes, 3 minutes late. Okay. Good evening, all of you, dear participant. Okay. There is some question from Canada. Please, are we going to have this material for practice, or how can I get the material for practice? Yes, we can provide you all this content. Okay. I will share this content in the WhatsApp group, and then after you can do practice on. Okay. No problem. Jyotsna, Dennis. Okay. Professor Jitendra, good evening, sir. Okay. So you are all regular attendee of the sessions, and thank you very much for spotting me. Okay. Just 1 minute. I have to. Restore. Okay. So now everything is fine, and I hope everything will go smoothly. Yes. Now this is the, and then I have MATLAB, this content, and okay, and sometimes I need required this one, 1, 2, and 3. Okay. Control L. Yes. So the thing is, these are the content which we are going to cover in the present session. How we can create the symbolic functions, we have already discussed in the previous lecture also, but here we will discuss all these things in very detail. Okay, and symbolic matrices, how we can perform symbolic computations on the, under this we have several topics, and all these content which we will cover in this session will be very highly useful in the coming sessions, and for like optimization techniques, scientific computing, symbolic tool is there. Okay, and then after numerical methods and many more techniques are there where we required symbolic toolbox. Okay, so this symbolic toolbox will help you in many ways. I think I have a little bit problem in the connectivity of my keyboard. Just I wait 1 minute, I check it. Yeah, wait. Okay. Hope so now it's fine. Yes. Yes, it is fine now. So here is how we can create a symbolic variable in MATLAB. So these are the some syntax, and by using this one we can easily create the symbolic variables, and we can write functions, then we can manipulate different type of operations by using these syntax. Okay, so the thing is, symbolic function represent the math function. Use symbolic function for differential integrations, solving ordinary differential equations, or other math operations. We can create symbolic functions by using sim function. Okay, sim function is there, and we use sim function to write the symbolic function. Okay, first we need to declare the variables, and then after we can easily write the function. Okay, so as you can see here, you can see here, okay, yes, so here is, this is the notation for the symbol to declare the symbolic function. Okay, so since x and y are the variables, and we usually use this sims to declare the symbolic function. Okay, so first we need to require a function which variables are involving there. Then after we can easily create the function, and we can do different type of operations for differential equation, to differentiate, to integrate, to pass any numerical values, as well as we can pass the other function to also. Okay, so this is the syntax for the same. Here f is a function of xy, and fxy is equal to, we have x square product y. So here exponent is used for, the meaning of this one is like x cap y. The meaning of this one is x raised to power y. Okay, and this sign we are using for the product. This sign is used for product. Suppose if we have any equation like we want to write a function like in this way, fxy is equal to, we have sine x square plus y square. So the syntax for the same will be like in this way, fxy will be equal to sine x cap 2 plus y cap 2. So this is the syntax in the MATLAB. Either you can use like in this way, sine x product x, okay, plus y product y. So it depends upon you how you want to write your code. So this is the simpler than this one, because if we have x raised to power 3 or 5 or higher degree of x, in that case we always this expression always suitable. Okay, so now when you will enter, this expression will return in the symbolic form, and after that we can pass the values in this function. So if you need to find out the value of this f function 832, so this is the value of x and this is the value of y. We can easily pass this value through this function, and this is the expression f32, and when you will pass the value, this will return 18. So the syntax which are presenting in this form are the syntax which are used in the MATLAB, and the other text as you can see here are for just the information about the topic and the content, how we can use. Okay, so now along with we will use MATLAB, so that all the concept will be very clear, and this session is also, as you know, always hands on, so that yes, so see in the MATLAB also, yeah, we are using here sims, and f is a function of in the place of command window I am using here a script file. Okay, control, when I will press control N, new script file will open, and I want to save this file with the name of control S. Okay, and I have to save this file on my desktop. So these are the tutorial 2323, and I want to save this file this one in this folder. Okay, and the name of the file is live session. This is 8th session. Okay, yes. So here we are using here sims, then I have f function with the variable of x comma y. Okay, so now if I write the function f x comma y, I have is equal to, suppose it is x square, then a product I have y. Okay, by using semicolon we can easily suppress the statement, and then if we want to pass the value through this function, we can use, suppose it is 3 and 5. When we will run this file, see, okay, change the folder. Yes. So here you can see in the command window, these are the statements. Okay. These statements are run and the value we have is this one, 45. Either you can save this value in this expression z is equal to, okay, see again, yes, we have z is equal to 45. So we can use here also CLC and clear, okay, CLC and clear. Yes, now it's fine. Also, you can use this like in this way. If I have x is equal to 1, I am using here x is equal to 1 and y is equal to 3. Okay. And then I have z is equal to, here is x comma y. C. Okay, so in this way you can use the values at this place. You can easily manipulate, you can change, and you can do use this file in a different way. Okay, so now, yes, the another way to use the expression here is symbolic function accept the array inputs, okay, and we can calculate f for the multiple values of x and y. See here, this is the x variable, and x variable is in the form of array from 1 to 5, and here is y variable, that is also from 3 to 7, and we can easily pass these values to the function. Okay, see in the MATLAB, along with we will do all this. Yes, and minimize. If we choose here, x is from 1 to 5, and y is from 3 to 7. Okay. And when we will execute these values, see, okay, but the thing is, when you are using array, the length of both the arrays must be equal. So you must keep in mind while using array. Okay. Good evening once again. Good evening, all of you. Okay. So now, if you have any question during this session, you can put your question in the chat box, and I will try to justify you, because I can see a parallel all the chat or the questions which you can put in the chat box. Yes. Also, we can differentiate this f function with respect to x, and for the differentiate, we have the function. If you want to differentiate, then for differentiation we have this function in the MATLAB. This is inbuilt function. See this statement very carefully. dfx. Okay, dfx is the variable, and this operation will be stored in this form. Okay, so when you will differentiate, this will return the value. See in the MATLAB how we can use this dfx, and okay, we have the MATLAB. Yes, see here. If we want to differentiate, I just 1 minute. I comment all these statement, And for the comment, we always use Control R. Now we have a new statement, that is df with respect to x. We are going to differentiate, and here is diff function. Okay, diff function is there, and we want to differentiate f with respect to x. C, and then enter here dfx. So when you will enter this is the derivative of f with respect to x. Once again, see here, if I remove this semicolon, I removed semicolon from this place, and when I will execute, yes, this is the derivative of the above function with respect to x. Okay, either you can use this statement in the command window also, CLC, and when I will enter, okay, so this is the syntax to differentiate. If you want to differentiate with respect to x, with respect to y, then you will do in this way. So now this is the derivative of the above function with respect to y, and this is the corresponding answer. Got it? Okay. So if you want to pass the value in the derivative which you got, and at the end you have x is equal to y plus 1. Okay. The value of x is in the form of y plus 1. So here is the syntax for the same. Yes. See very carefully. So in the previous, we got the value of this expression. Okay. The value is this in this form, dfx. Okay. And this is in this form. And now you want to pass the value which is for x, and x equal to, we have y plus 1. What we do? We just put this value at this place. Okay. And when you will run this code, this automatically simplify the above expression, and you have the answer corresponding to the above statement. So just we need to follow and understand the syntax, how we can use for the simplification. Okay. So 1v1 we will do the experiment, and I will try to explain all this. Yes. Now we can easily create symbolic matrix. So in the when we want to establish the symbolic matrix, naturally there will be all the variables, all the element of the matrix will be in the form of variable. Okay. If we directly try to write here, see, this is a CLC. Okay. And yeah, if I want to write the matrix, A is equal to, this is the syntax, like 1, then 2, 3, then I have, suppose it is 3, 4 and 5. So when I will enter, see, so there are 2 rows and 3 columns. These are the numbers. If in the place of numbers I have some symbolic variables, so what I will do, I should replace all these. Suppose these are A, B and C, semicolon. I have B space C and A. Okay. Yes. So when I will enter, what happened? Because these are not defined. These are not defined. That's why this error occur. Okay. So what should we do? What should we do? Which are involving in the matrix. So in the matrix we have these variables a, b, c. Okay, and a is equal to, we can use these variables in the matrix in the place of 1, 2, 3 where we want to use comma or single space. Okay, this is the first row. Then first row will be break by using this semicolon. Next row will start. Then we have the second row, break the row by using semicolon. This is the third row. So when we will enter, we have this matrix corresponding to the above inputs. Okay, so here is a very simple way to write this code. Okay, so here yes, I am again using here script file. Here is sims and a, b and c. Okay, and I have a is equal to a, b, c. Okay, then we have b, c and a. Then break the row. We have next row is c, a and b. Okay, and you can suppress here, you can suppress and again run this file. Now you can see there is no error. There is no error in the command window. When you will you want to print this matrix in the command window, what you will do? You will do here, just enter a, because the information this has been stored in a. Okay, so the information on the right hand side has been stored in a. So when you will enter here a, and you can see this is the matrix of 3 by 3 order and there is no error. But while using please can you scroll up the start of the script file? I think I miss something, my code is not running. Okay, in the previous you can see, just I'm doing here undo. I'm doing here undo. Yes, so here you can see this is the first line and this is the sims fxy. This here is the function f(x square y). Okay, and here is the derivative. Okay, dfx. This will return the derivative of f with respect to x. See here very carefully. Remove this quote, remove this semicolon. Okay, now you can see in the, you got it? Yes. So also if I remove all these comments, yes. So when I will remove these comment, what happen? I am commenting this one. Now what we have? We have x is an array. You can pass the values of array. X is these values are 1, 2, 3 up to 5, and the values of y are 3, 4, 5, 6, 7. Okay, so these are two arrays, and the values of these will pass through this function. Okay, so when I will run this one, yes, this is the corresponding answer. You can see here the corresponding answer. Got it? Is it fine now? Is it okay? So we were talking about Control Z. Yes. So here is this is the matrix, and how we can create symbolic matrix with the symbolic variable. Okay. So a circulant matrix has been the property that each row is obtained from the previous one by one cyclically, promoting the entries one step forward. And this is the example which we have presented. And also you will get this file of the presentation in the WhatsApp group along with the previously presentation also I will share with you, so that this content will be helpful for all of you. Okay. Now this is the operation. We can get to the values. Okay. See the very carefully what is the meaning of this operation. If A is a circulant matrix, the sum of the element over each row and each column is same. Okay. So we can easily find the sum of all the element of the first row. If you want to get to the first row, we have this syntax. Note this syntax, as you know, in the very first when we cover the topic over the matrix and determinant. In that case, I clearly explained about how we can extract first row, second row, first column, second column, any column or any row from the matrix. Okay. So this syntax is we have the A matrix. Okay. And from A matrix, which is in this form, A, B, C, B, C, A, and C, A, B. Okay. So if you want to extract this, this first row, you want to extract this first row, then you have to use this code. Note this one very carefully, and we are using again and again. This is the syntax. If you want to extract the second row, then we will use in this way. If you want to extract first column, then first column or second column, then what you will do? You will do in this way. A, comma, here is a colon are used here at this place, then comma and 1. This is first column. If you want to extract third column, this one only, then you will use this code. This is the third column. So in this way, by using this syntax, we can easily extract any row, any column. So here is, this is the first row. Now we want to check sum of the element in the first row. So some function is there. This is also inbuilt function. So here is some function is used to add each element of the first row, and when you will execute this statement, we have this answer. Note very carefully. Okay, you need to operate all these operations to extract first row, second row, any column or any row. Okay, this will help you in many ways in the coming sessions for your writing program. You can easily extract when you have the data in Excel format, you can import in the MATLAB, and then after, if you need to uh, and you need the statistical analysis, then you can easily extract by using these operations. Okay, you can extract any row or any column from the Excel. What you need to find out the mean, median, or other type of statistical analysis you can do. So here the another is we can check if the sum of the element in the first row is equal to the sum of the elements in the second column. Okay, so here is the function is always. Is always function is used to verify, to check the logical operations. Okay, so you can see here we want to compare one row and one column, sum of one row and sum of one column. So here is, this is the function, is always, and here is the statement, sum of A1 comma column. So this is the first row, sum of the element of the first row, and this is the sum of second column. Okay, and then as you can see at this place, the same syntax at this place, and you know this is the logical operator which is used for equal. So double equal in the MATLAB becomes logical operation. This, the meaning of this double equal in the MATLAB is equal to. Okay, the meaning of this one is equal to. Note this point. We are usually use like in this way, A is equal to 3. The meaning of this expression is we have assigned the value to the variable A. 3 is stored in this one. But if you are using 3 is equal to 5, we know there is no sense in the MATLAB. But if you want to use or you want to check, then whether 3 is equal to 5 or not, then you have to use logical operation 3 is equal to 5 or not. Okay, see this one also in the MATLAB. This is very important to explain also. Sometimes I go to the questions related to this. See, CLC, yes. If I am using here 5 is equal to 2, what happened? It returns error because 5 is number, 2 is number. Okay. So to compare these numbers, we have to use logical operator. See now, 5 is equal to 2. Now this will return some sense. Either it will be true or it will be false. Okay. See. So this is a logical operator here and it is declaring 0. Means it is false. Okay. Similarly, if you want to compare two numbers, 5 is greater than, this is also logical operator. Yes, 1. 1 means 5 is greater than 2, means it is true. Okay. And if you are using f is less than or equal to 2, this is also logical operator. See, 5 is greater than and equal to 3. Yes. False. Sorry, it is also true. Okay, 5 is greater than 3. Okay, so all these are logical operators. Okay, so now we were talking about this one and come back in the MATLAB. So first we are going to write here. We are going to write, I want to remove all this A, comma, B, comma, C. Then semicolon. Again, I have B, comma, C, comma, A. Semicolon. Then I have C, comma, A, comma, B. Okay. So either we can use a space, single space, or comma. So when we will execute this statement, yes, we have this A matrix. You can see we have A matrix. Now we, okay, comma, and this one. Yes, when I will enter, you can see this is the first row, and you can find here the elements of first row. Okay. If you want to extract a second row, then yes, just you need to replace this value, and when I will enter, this is the second row. If you want to extract any column, what you will do? Here I have to use column, then 2. Okay, this will return second column. You can see here, yes, compare second column, and you can find here the elements of second column, BCA, and these are also BCA. Okay, you got it? Canada, I think your code is working now, and don't worry if you have any mistake. I will provide you the this presentation. You can compare your code with this file. Okay. So now you should concentrate on this problem. So now what we want to find out the sum. We are using here sum function, and to find the sum of the elements of the first row. Okay, we want to find out sum of the elements of first row. Okay, this is the first row, then comma and colon. So this will return the sum of first column. Okay, I want to store this information in S. See, yes, S is equal to A plus B plus C. S means sum of the elements in the first row. So the information is stored at this place. And I am using here S1. I am using here S1. S1 is sum of the elements of second row. Okay, so for the second row, first we need to second column. Okay, so we need each row. So this is what this column will do. This will extract all the rows in the matrix. Okay, and we need second column. See, yes, you can see here the sum of first row is this one, and sum of the second column is this one. Both are equal. Okay, you can compare here. S is equal to S1. S1. This is the logic operator we are using here, and then enter. So you can see both are equal. A plus B plus C is equal to A plus B plus C. Also, you can use this statement, is always statement. Okay, is always statement we can use here. See in the MATLAB how we can use. When we will comment the statement, that will not be the part of the program. Okay, so now these statements are not the part of the program. Okay, is always, then sum of comma colon, This is the first row of the matrix. Then A is equal to sum of, note this statement very carefully, and the code is always very sensitive in MATLAB. Sum of A, we need second column. Okay, yes. So when we will run this code, okay, the element while creating a matrix. So here the thing is, if there is a network issue, please let me know. Everything is fine from my side. Okay. Please comment in the chat box whether I am properly audible. Is there any kind of buffering so that I can remove? Please put in the chat box. Okay. So here is sim function can be used to define the symbolic matrix or vector without having defined its element in advance. Okay. And sim function will generate the elements of the symbolic matrix at the same time that it creates the matrix. The function presents all generated elements using the same form in a row index and column index. By default, sim separate a row index and column index by underscore. Okay. For example, you can see here, if you are using this code, and you can see we are using here sim function. Okay. And this is the matrix. And the matrix will be closed by using quote sign. And this is the order of the matrix, 2 by 4 order. There will be 2 rows and 4 columns. So when A is equal to sim function, okay, then we have double quote sign. Here is A, and then comma, and this will be the order 2 by, we can use 2 by 4 or 2 by 3, depends upon our choice. Okay. So when I will execute this statement, this is also not required. This is not required. Okay. See. So the element will appear in the command window, as you can see here. Underscore is there. This is the first element. This is the second element. Okay. A12. So if you want to remove this from, you can do by using this notation. We have to replace the notation. As you can see here, a double percentage is there. Note this notation. If you want to control the format, we can do easily by using this syntax. Just we need to replace a into a percentage d. So this will replace the output in the standard format. Okay. Yes. Just we need to replace at this place a percentage d and percentage d. Okay. So when I will run this code, yes, now it's fine. You can check it. Now percentage sign disappeared. Okay. There is one more particular type of matrix, and sim can be used. Sim is used to convert a matrix from the numeric to symbolic. Okay, and here is A is equal to Hilb. This is the Hilbert matrix. Okay, of third order. So when you will use this command, this will return this matrix. Okay, these are the corresponding element of the matrix, and the matrix will be of 3 by 3 order, Hilbert matrix. Okay, so this command will be used to generate 3 by 3 order Hilbert matrix, and we can easily convert this numeric into symbolic form by just using a very simple statement. Here is very simple statement which we will use here. Yes, so by using sim function, we are using sim function to A. Like in this way, we will pass the above matrix through sim function. This will convert all the floating values into the symbolic form. And as you know, symbolic values are always exact values. So here we can precise the symbolic form of 3 by 3 Hilbert matrix into symbolic format. Okay. If you want to check in the MATLAB, we can do C in the MATLAB. Okay. Yes. So we are using in the MATLAB. Comment this one, control, then enter. We have A is equal to Hilbert. Okay, so this is the third order, and when we will execute, you can see this is the matrix. If you want to change this value, we are taking at its place, in the place of 3, we are using 5. Okay, we are using 5. So this is the Hilbert matrix of 5 by 5 order. Comment this statement. But now we want to convert into symbolic. What I will do, A is equal to sim, then A. So the above matrix of fifth order will pass through this statement, and when I will execute this statement, okay, see, now the values has been changed into the symbolic form, and you can easily recognize the values. The first row and first column are same. Similarly, second row and second column. Also, this is the symmetric matrix. When you will convert rows into column, this will remain same. You can check it. Okay. So now we are going to perform some symbolic computations, and in this symbolic computation, this part is very, very important and useful to all of you. We will cover differentiate symbolic expression, integrate symbolic expression, how we can solve the equations, simplify symbolic expressions. Then we have substitution in the symbolic expression, and at the end plot symbolic functions. So these are the parts of this session. Okay, so all these we will cover one by one. Here first we are going to differentiate one variable function. So to differentiate a symbolic expression, use diff command. So to differentiate, we have diff command is there. This is inbuilt function in the MATLAB, and whether you are going to differentiate partial or ordinary derivative Always we have to use this diff function. And by using the statement, this function, we can find out higher order derivative also. Okay. So for the first derivative of a symbolic expression, we have a simple example. You can see here is sims. So first we needed to declare symbolic variable. Okay. And because if we have a function that will be depend upon some function, some variable, so we need to define here which variable will be used for our function. So we are using here x is a variable and f is a function of x, which is sine x square. Now we want to differentiate this function. Either you can use diff f. By default, if you are using diff f, it will return the derivative of the above function, which is 2 product cosine x product sine x. Also, you can use in this way diff f comma x. Suppose f is a function of 2 variable or more than 2 variable, and you want to differentiate with respect to one variable. In that case, we can use this one, and by default, this will take the partial. This will take the derivative with respect to x only. Okay. So while using this syntax, be always careful, and you need to verify whether you are using the syntax are correct or not. Also, for the higher order, sometimes if you need higher order derivative, you can use in this way diff f comma x and 5. So when you will use this syntax, this will return 5th order derivative of the function. Okay. See in the MATLAB. Yeah. We have, yes. Here I am using sims x. Okay. And I have, suppose f is equal to, I can take here is sine x square. I am taking in this way, sine x square. Okay. And now dx is equal to, I have diff f. Okay. So when I have this very small statement, or you can say it is df. Okay. So when I will run this code, you can see this is the derivative of this function which we choose at its place. Either you can replace at this place f comma x. This will return also the same answer. When I will run this code, I am again run this code. Yes. Okay. The answer is same. Sometimes if you need higher order derivative, if I am using here 2. Okay. So this is the second order derivative, you can see. If I choose here 3, then this will return third order derivative. If I have at its place 9, this is the ninth order derivative. Yes, the answer is very long. Answer is very long. Okay. So I am using here only 5. Yes, this is the 5th order derivative. And if you are using here, I am using here Pretty function. Okay. Pretty function for dfx. See, This is the 32 x square x raised to power 5 cos square x. Then we have minus 120. This 2 is at its place. Okay, x square. You can check all these values. Okay, so this row, this is in the form of Pretty. Okay, or either you can use dfx. Yes, so this is the required answer you can find here. So all type of order by using this one you can easily do in the MATLAB. Now if we have a multivariable expression, we can differentiate with respect to any variable. If you do not specify any variable, then MATLAB choose a default variable by its proximity to the letter x. Okay, so the thing is when we have a function involving two or more than two variable, so here we have a function, example is involving two variable x and y, these are the symbolic variables. Then we are taking here f is a function which is sine x square plus cosine y square. So the meaning of this one is we have this function, okay, f is equal to sine square x plus cosine square x, and the syntax for the same is this one. Okay, if you have the function like in this way, sine x square plus cosine y square, okay, sorry, here is y, then the syntax for this one will be f is equal to sine x cap 2 plus cosine y cap 2. Okay, so see the difference between these two. So this this syntax is for this function, and when you will differentiate this function with respect to x, or whether you are using only this expression, so the meaning of this one is this will take partial derivative f with respect to x, and this will return the answer this one. Okay, I think you got this explanation, and see also in the MATLAB. See in the MATLAB. So here we need to choose one more variable. We are taking here y, and f is equal to, we have sine, here is sine square, plus we have cosine y, and then square. And see here one by one. Now, what is the meaning of this expression? See, this is the derivative of f with respect to x. And if I am using here comma x, then it is also with respect to x. Okay, we have the same answer. Now, if we want to differentiate with respect to y, then this is the partial derivative of the above function with respect to y. Okay, this is, there is no y variable in this part, and this term only contain y variable. So when you will use this this expression to differentiate f with respect to y, so this term become constant and not appeared in the output. Okay, Sometimes if you need mixed partial derivative with respect to x as well as with respect to y. Okay, so here is you can use 3. This will return the partial derivative of third order. Okay, you can check it. You got it? Okay. Still my voice is clear because sometimes I am observing that my system is buffering today, other system. Okay, and if you have the problem, please you can put in the chat box so that I can rectify it. So this will return the third order. Okay. Yes, this is the third order. Now, if you need mixed derivative, then how you can do? If I am using here y and x, okay, see, it is 0. It is 0. So this is the mixed partial derivative. So when you will differentiate with respect to x, then y will be variable and y will be fixed, so this becomes 0. And again, when you will differentiate with respect to y, so the whole terms becomes 0. So the partial derivative of this expression with respect to x and y will be 0 as according to our function. If here is product sign, see, now we have this corresponding answer. You got it? Please let me know if there is any problem because I am not getting voice in my other system. Okay. So here is one more example you can see. Yes, we have already discussed all these concepts which you can see here. This one, and again when you will use this diff, this will be this one. Okay, so this expression will return the value of this expression. Okay, and this is the corresponding syntax of the same. System, I have a problem. Okay, thank you to update me if there is no problem. Yes. Okay, so here is now how we can integrate symbolic expression. So there are two type of integrations which we are covering here. One is indefinite and definite integration, and also we have integration of multivariable expressions. Okay, so these will be covered in the session. Yes. So for the integration, we have a function, inbuilt function in the MATLAB, and to integrate for the integration, we have int function. Okay, this is the int function which is used for integration. Okay, so this is the syntax. We are covering the one variable function and how we can integrate. So since x and f is equal to sine x square, we can find the indefinite integral by using this statement. So this statement will integrate this above function with respect to x. Okay, so this is the answer. This is the answer of this operation, and f is this one. Okay, so this value will pass through this int function, and when you will enter, the corresponding answer will return in the command window. You can do easily. You got it? Okay. See here, you can see here are multiple variables and expressions are there. So depends if the expressions depends upon the multiple symbolic variables, we can designate a variable of integration. If we do not satisfy any variable, then MATLAB will choose by default with respect to x. Okay. See here we have x, y, and n. This is the function. F is equal to x raised to power n, y raised to power n. This is the function. We want to integrate this expression with respect to x. Okay. So either we will use this syntax or we will use this expression. Both will return the same answer. So after integration of this expression, we have this is the returning value when you will enter the above statement. So this is the integration with respect to x. If you want to integrate with respect to y, okay, then we need to use this syntax int f comma y. Okay, for x you can use one of these, but for y we have to use only this one, because x by default it will take always, or you can make it specific. But if you need with respect to y only, because f is a function of x, y, and n symbolic variables. Okay, so we have to use this expression, and this will return the corresponding answer, integration of f function with respect to y. Okay, you can check all these in MATLAB also. Here we are using, yes, we are using here x, y, and n. X, y, and n. Okay. X, y, and n. Suppose I have f is equal to, we can take this function, okay, x raised to power n plus y raised to power n. Then integrate. For integration we are using int function, and f, when we will execute this statement, you can see we have the integration of this expression with respect to x. And if you want to integrate, with respect to y, you can use in this way. Yes, this is the integration with respect to y. If you want to integrate this expression with respect to n, you can do, because here n is a symbolic variable. So this is the integration of this expression with respect to n. Okay, and also you can use this syntax for x. Okay, one. x comma y. See what happens. This is returning the answer in this way. Okay, very long answer. So if we use int, then bracket, here is y, and when we will execute. So this is the answer for integration with respect to y, then with respect to x. We have, this is the answer. So in this way, you can integrate with respect to both the variables. Now, this part also has been discussed. This is also has been discussed. Okay. Also here you can see the definite integration. Okay. So sometimes if we have a function and we want to check the definite integration, please, I have 1 minute, please. Just 1 minute. See the code and try yourself in your system the expression which you can see here. Please try, if you have a system, try this code in your system. Please check it in your system. Okay. You can, yes. Are you trying? Please check it in your system. Okay, everything is fine. I hope so. Everything is going well. Okay. Yes. So you can easily pass the values. Okay. Here is, if you want to find out the definite integral, that is very quite simple. See here, this is the syntax, and this is the limit of x variable. This is the limit of x. You can pass the value in this way. This is the lower limit and this is the upper limit. See in the MATLAB. See in the MATLAB. Okay. And here is the MATLAB. Yes. We are taking the function. Okay, thank you. Thank you very much. Yes, I am taking here f is equal to a very simple function. Suppose it is x square plus y square product sin x. Okay. Take simple function. Take simple so that we can. Yes, I'm taking here only x. Okay, this is the function, and int f with respect to x. Then we have 1, 2. Okay, see what happened. Yes, so you can see this is the syntax for the integration for definite integral. Okay, so this is the integration with respect to x, and then we have the no problem if you choose here e raised to power x, exp. Exp is exponential function, and we can use for the same. This is the answer. You can see here. You can replace the functions according to your choice. This is the note of the problem, because I am taking the simple example so that I can easily explain, and you can also compare your answers. Okay. If you have the y limit, yes, if you are replacing this x into y, we are replacing with respect to y. See, so this is the corresponding answer. Now the limit are definite. Okay, for multiple integrations, you can do for the multiple integrations. Okay, now if you have this is the y from 1 to 2, see here again I am using one more function, int. Okay, then we have this one, and I want to integrate with respect to x, and the limit of x is, suppose it is 0 to 1, 0 to 1. Okay, see, this is now there is no variable. There is no variable because this is the definite integration, and the answer is in the form of a symbolic. Okay, if I am changing this value here is sign, see, I have this answer. Okay, if I replace it as log, okay, you can take any value. The answer is -2. Okay, so there are different type of expressions, and we are using, and we can do. Okay, now I have how we can solve the equations. Okay, we can solve the different type of symbolic equations by using the solve function. Okay, this function will be used to solve the equations. Algebraic equations, one variable. Then we have algebraic equations with several symbolic variables. Then we have system of equations. So all these type of equations we can do easily in the symbolic format also. Okay. See here. Yes. So when you want to solve the equations, and you must understand how you can write an equation in the MATLAB. This is very important. So the double equal sign is used for equal. Okay. To define an equation, and we can solve the equation by calling the solve function. This is inbuilt function in the MATLAB, and this solve function will solve the equation. So here is, we have very simple example. We want to solve this equation. Equation is x cube minus 6x square is equal to 6 minus 11x. So this expression is here, and the expression on the right hand side we have is this one. For the equal sign we have double equal. Okay, double equal is used for equality. Okay, for equal. And this is the solve function. This solve function will solve the equation in the symbolic form, and this will return all the values of x which will satisfy this equation. Okay, so when you will execute this statement in MATLAB, this is the answer. Okay, this is the answer. If you want it in MATLAB, you can note this statement on your notebook. You should try the syntax in your MATLAB if you have. Okay, you can do in your MATLAB. So first you need to declare the variable, and then after you can do. Okay, see in the MATLAB we have SimX, we have SimX, and we want to solve the equation. Equation is x cube. Equation is x cube minus 6x square minus 6x square then is equal to 6 minus 11x is equal to 6 minus 11x. Okay, so we want to solve this equation. Equation is correct. X cube minus 6x square is equal to 6 minus 11x. Yes. So run this one. We have the answer. Got it? I hope you got it. Similarly, if see this one very carefully, sometimes if you not specify the right side of the equation, then we can rewrite this expression without using this one. Okay. See here we have the statement x cube minus 6x square plus 11x minus 6. So you need to shift all these terms on the left hand side, and it becomes equal to 0. Just we need to consider only this part. Okay, and we are not using this sign. You can do in this way also. Yes. See in the MATLAB what we are doing, we are not using this equal. So 6 becomes minus 6 and the minus becomes plus 11. Okay, and this will also return the same answer. You can check it. We got the same answer. I hope you got this statement. Very quite simple. Now if we have equation involving two variable and we want to solve for one, you can do also. So here you can see equation is involving two variables x and y, and then we are using here the solve equation. The equation at this place we have is 6x square minus 6x square y, then plus xy square minus xy plus y cube minus y square is equal to 0. And we want to solve this equation for y. Okay. So this is the syntax you can see, and this equation is equal to 0. Okay. So the syntax for this equation you can see at this place. And we want to solve this equation for y. So this will give us the values of y in terms of x. And when you will enter, we have the corresponding this solution. If you want to try yourself, you can do. Okay. Very quite simple. Then if you want to solve this equation with respect to x, then this will return the values of x in terms of y. Okay. Just 1 minute, I also trying in the MATLAB, and it will be better for all of you. See. I have x and y, okay? X and y. There are two symbolic variables. The first term is 6x square. First term is 6 product x square. Okay. Then we have minus 6x square y minus 6 x square y. Okay, 6x square y. Then we have plus xy square. xy square plus x product y square. Okay. Then we have minus xy minus x product y. Then we have y cube minus y square. Y cube minus y square. Okay. Is equal to 0. And we want to solve this equation with respect to y. Say we have, this is the equation. Okay. You can choose any equation, no problem. So when we will execute, you can see we have the answer in terms of y. Okay. And if we have at this place x, then we have the answers in terms of y. Again, you can check it. Here is y. The answer will be in terms of x. And if you want to solve this equation with for y, for x, okay, then answer will be in terms of y. So in this way, you can do numerous experiments on these problems. Now, if we have a system of equations, we can do function is used for the system of equations. So this is the first equation. X is equal to 4x. This is the second equation. X is equal to y. And this is the third equation. Z is equal to x square plus y square. And on the left hand side, we are using this one. So after solving these equations, we have the value of x, y and z. So the solutions will be stored for the x variable, for the y variable, for the z variable. So when you will run this code, you have the value of x. There will be two values for x, because here is x square, here is y square. Okay. So here is, these are the values of y and these are the values of z. You got it? I think it is very quite simple, and you must try yourself in the MATLAB. Okay. Again, we can simplify symbolic expressions. So a symbolic method tool provides a set of simplification functions, manipulate the output of a symbolic expression. For example, we are solving the polynomial of the golden ratio of phi. Okay. See here, phi is equal to, we have 1 plus square root of sim 5 upon 2, and this is the value of phi, which is golden ratio. F is a polynomial, phi square minus phi minus 1. So when you run this, when you will run this code, so this will return the value in this form. F is equal to, this is the value in the symbolic format. Okay. And if you want to solve this expression, we have function simplify. We have the function simplify. Okay. And when you will use the statement, we have very short answer, that is 0. Okay. So this is the expression in the symbolic form. Okay. And when you will simplify this expression by using this function, the answer of this expression will be 0. Okay. When you will pass this value through this polynomial, it becomes 0, because this phi is solution of this expression. So I am not doing MATLAB experiment by using this statement. After getting this file, or if you have the system, you can do experiment parallel with this session. Okay. So the thing is symbolic simplification function in the MATLAB, because the meaning of the simplest representation of a symbolic expression cannot be defined clearly. Different problems require different forms of the same mathematical expression. Knowing that what form is more effective for solving your particular problem, you can choose the appropriate simplification function. Here are some more examples for the same. As you can see here, f is equal to this the here f is equal to this the expression x square this is the one factor, x square minus 1. Then we have this expression, which is the polynomial of 4 degree, x4 plus x cube plus x square plus x plus 1, and then we have this one and minus x. Okay. So when you will use expand function, expand is also inbuilt function in the MATLAB, and you can use that, you will get this. Okay. Which is x cube plus 6x square plus 11x plus 6. So when you will expression G is no possibility to return the same polynomial. Okay. So when you will use a different type of example for your experiment, then this will become more clear for you. Okay. Yes. Here is also one more interesting type of factor which you can use. Okay. So here is Horner, or you can say nested representation of a polynomial is the most efficient for numerical equations. Sometimes we need this type of expression when we need numerical solutions, and we use Horner or nested function. So here is the expression h is x5 plus x4 x cube x square plus see this one into in this form. As you can see at its place. I hope you got it. If you have any question, you can put in the chat box. Now, substitution in the symbolic expression is used for the to substitute the value. We have the subs function. Okay, we have subs function. You can see here. This is the syntax for the same. If I have the polynomial f and I want to check the numerical value for x is equal to 1 upon 3. See, for the example, f is equal to, this is the polynomial, which is 2x square minus 3x plus 1. And if you want to pass this value through this function, okay, so subs function we will use f comma 1 by 3. So this is the value of x. And this value will pass through this expression and it will return the value 9. Okay. And the other most important thing is subs function does not change the original expression. After operating this expression, when you will enter f in the MATLAB command window, you will have the same polynomial. Okay. See, the meaning to say, this is the MATLAB expression and this is the MATLAB, and we are doing the same. Yes. So here is if there is y, no problem. Suppose I have f is equal to x cube plus 3x square, then I have minus 2x. Okay. And I am using here subs function f comma 2. So when I will run this code, the answer is 16. Okay. Again, if I will press here f, see, I have the same x cube plus 3x square plus 2x, which was at its place. So the sub function will not replace the function; it remains same. X, then you will use the command in this way, comma x comma 3. So this will pass the value of x is equal to 3. If you want to pass the value y equal to 6, okay, then you will use this code subs f y 6. Okay, so this will return this answer because there are two variables. and we are using yes, see here, I am using x and y is there. We are introducing here some more expression involving y. Yes, so here is a product y cube. Okay, and also there is one more term y square. If I want to pass the value of x, which is 2, see the answer. If I want to pass the value of y, now the value of y will pass, but f is involving x and y, two variables. So the answer will be in terms of x. See, we have the answer in terms of x. Okay. If again you want to pass the value of suppose it is g equal to this expression, and h is equal to, I have subs. I have g comma x comma a. So the meaning of this one is, in the first step we are passing the value of y, and in the second case we have the value of x. See what happened. We have h is equal to 10. For x equal to 3 and y is equal to 2, we have the value of f is 10. Okay. The value of f is 10. You can use in this way. Okay. F is equal for another variable. Okay. Here is x and y, and this is the function. Okay. So when you will, the meaning of this expression is, we have y is equal to x. This is y. Okay. We are replacing the value of y. Okay. So at this place, we want to replace y into x. Okay. So this is the syntax for the same, and when you will execute, this will f is equal to minus 24a plus 350i. How you can do? Very quite simple, and you can follow the syntax which are available here. So first we have the polynomial, then we have a matrix. A is equal to this one. First two elements are 1, 2, 3, and second two elements are 4, 5. Subs function we are using here fa. So this matrix will pass through this polynomial, and after simplifying, the values of a cube, the value of a square, the a and identity, then multiply with the scalars, and after simplifying we have this answer. Very interesting part of this substitute. If you need to pass a matrix through any polynomial, we can do easily, and this will be, there will be various use of this type of problem. Okay, so we have very less time. I will take only 5 minutes more. These are very simple and plot symbolic function. Okay, symbolic expression, equations, functions in Cartesian coordinate. Okay, and plot f plot 3, this one, Ez polar. To create a plot in polar coordinate, we use this function. F surface, we use these inbuilt functions. F contour, to create a contour plot, and F mesh is used to create the mesh plot. Okay, so these are inbuilt functions and very simple to use. I am showing you some examples for the use of this. I have yes. So if you have this type of equation, x cube minus 6x square plus 11x minus 6, and you can easily use fplot function, and this is the syntax. You can see this is the same manner to write the equation, just we are using fplot function. See carefully. The other things are very same, just we need to use only this thing. Okay, and this will return the plot of the equation. See, sorry. Just 1 minute. Just 1 minute. Okay. Just 1 minute. What happened? These statement. By using these statements, you can have X label, Y label, title, grids also there. Okay. Similarly, if you have implicit function, we will use f implicit. This is the inbuilt function in the MATLAB. See here, plot the equation we have is this equation. I am writing this equation again. This is x square plus y square whole power is 4 is equal to x square minus y square whole power is 2. We want to plot this implicit function in the range -1 less than x less than 1. Okay. See, this is the corresponding syntax. Same as xy, and this is the equation you can see here. And the most important thing is f implicit function. Okay. Equation, comma, this is the range. This is the range of x, which is -1 to 1. And when you will execute these three statements, this will return us the corresponding graph. You can see here. Okay. Again, if you have the equation in the form of parametric, then you will use fplot3 function. Okay. Here is x is equal to, equation is x is equal to we have t square sine tan t, and y is equal to we have t square cos tan t. Okay, and z is equal to t. These are three equations. You will use fplot. This is the first equation. This is the value of x. This is the value of, this is the corresponding graph. Okay. And for the surface, if you have z is equal to x square plus y square, we have f surface function. Only 2-line statement code is there, and this will generate the surface. Okay. So in this way, we can use all these functions, as you can see here. A few examples has been presented. And I hope the session will be very helpful to all of you. Thank you very much to see this lecture till the end.